I'm going to go ahead and present about including crowdsourced cycling data in prediction of bicycle counts. And I think everyone is aware that if you want to plan for bicyclists, for example, you have to know how many are out there. If you want to plan for pedestrians, then you need to know how many are out there. If you don't know how many people are walking, how many people are bicycling, or how many people will be bicycling in your area, then there is no way you're going to plan well for them. And we all know that it's challenging to get ways or to have means of estimating how many pedestrians you're going to have, how many bicyclists you're going to have. This study is focusing on how can we utilize crowdsourced data, data from other sources, sources that are different from traditional sources, to improve the accuracy of prediction models to estimate the number of bicyclists in a roadway. And as I said, there are different ways of obtaining data that you can use to develop methods or models that you can use to estimate the number of bicyclists in your area. But the traditional methods are challenging. First of all, it's high cost to use those methods to collect information about how many bicyclists you have in your area. But the second one is when you are using traditional methods, because of the cost, you tend to do it in fewer areas. So you don't have that much coverage of the area that you want to plan for. And you cannot do it for a long time. So you have this partial temporal issue that you face. But if you think about crowdsourced data, and when I say crowdsourced data here, I'm talking about data coming from, say, fitness apps that people use. I know many people are using fitness apps. People are using Fitbit. People are using Strava app to track their cycling activities. Can we put our hand on those data? And if we can we take that data and incorporate it in the other data that we get from traditional sources and be able to improve our ability to predict how many cyclists there are going to be in your area or in your roadway. So in this study, we used Strava data. And Strava is a very popular app. Many cyclists use it. And it tracks the cyclist as long as they put it on before starting their trip. And information that you get from Strava can be actually used to show you the origin and destination of those cyclists, which roadway they used, and so forth. So the map that is shown here is actually a heat map of Michigan, which is showing Strava users. So if we can get that information, can we incorporate it with other data to improve our estimation methods? So the goal of this research was actually to explore opportunities and limitations associated with integration of crowdsourced cycling data with data collected using traditional methods. This flowchart is showing how we did our research. We obviously did field data collection, and this field data collection involved surveying of cyclists, and we also collected video data to capture how many cyclists are out there. And then we had data that were from the archives. We had Strava data. This is data from Strava, which shows how many cyclists were using the Strava app when they were riding. And we had weather data, we had bicycle infrastructure data, we had sensors data, land use data. And we did descriptive analysis, and we came up with a way of predicting how many bicyclists are going to be on a segment or roadway segment by looking at different factors, including Strava data. So we did our data collection in two series, Ann Arbor and Grand Rapids. We had a total of 19 sites. We had 10 sites in Ann Arbor, and we had 9 sites in Grand Rapids, and that's how the sites were distributed along Ann Arbor, and that is Grand Rapids. That's where we had those sites. Now, if you look at these sites, we had different facility types. We had sites that had bicycle lanes, we had sites that had shared lane, we had sites that had nothing, we had trails, and we collected data from all those sources. And for video data collection, of course, we installed our video in such, our cameras in such a way that it was safe, and in such a way that we could actually see all cyclists that were riding on that segment. And this is more of a camera installation on roadways with different types of bicycle facilities. And we also used pneumatic tubes to collect the number of cyclists who were riding on trails. So as you can see, that's the pneumatic tube there in the middle, and that was actually counting how many cyclists were riding. So the efforts that we put on video collection and pneumatic counters were for the purpose of getting ground truth data. We wanted to know exactly how many cyclists are out there, and then take that information, compare with what we see in Strava, and see how we can utilize the information we have from Strava to develop some models that can help us predict the future number of cyclists in a given facility. And we did, after collecting the videos, of course, we did manual counting of how many cyclists were there. And we had a total of 1,500 hours of video data that we worked on. And Strava data, we actually acquired data for 2 cities, and it's not that expensive. I think I paid about $10,000 for the 2 cities for 1 year data. Of course, it gets more expensive depending on the granularity of the data that you want. So if you want more detailed data, you pay more. But for us, we thought maybe the data we got were sufficient to use. And the Strava data, when you look at those data, they give you activities by nodes. So each intersection, they give you information of how many cyclists passed that intersection in a given time period. And they give you information about how many cyclists were using Strava app when they were riding on a segment. And they give you information about the trip purpose. So Strava has a way of kind of looking at the trips and figuring out whether the trip was commute or was non-commute. And there is aggregated demographic information. So again, as I said, we had Strava data for the sites where we collected our ground truth data. So we had 2 data sets that we looked at. And the other thing that we did was we did a survey of cyclists when we were collecting data. And the goal of the survey was actually we wanted to see, get some sort of an estimation of how many people are using Strava app. And of course, get some other information from them. So one thing we found was that about 66% of the 321 cyclists that we surveyed, they were not using any fitness app. 16% were using Strava fitness app, and 18% were using other apps. There are other apps that people use to track their cycling activities. And when we looked at the demographics of the cyclists and compare with the proportions of people who are using Strava app and using other apps, what we found was that there is a high percentage of Strava app users between the age of 25 and 44 years. And people with age of 55 and above tend to use other fitness app, not the Strava app. And when we looked at the gender, we found that there is a high proportion of male cyclists who are using Strava app compared to female. That information is important. And we also looked at the trip purpose as part of the survey. What we saw was that cyclists were more likely to use fitness app when they were making recreational trips, not when they are on commute trips. Cyclists on recreational trips were more likely to be found on trails. So if someone is on a recreational trip, maybe if there is a trail, they're going to use a trail rather than using another facility. So data processing, we process the data. This is Strava data, and these two maps are showing how the data are distributed on these two cities. And as you can see, the red is showing that we had high Strava users, and the blue is next, and the gray is the lowest. So there are specific areas where you see a lot of people using Strava apps, but not everywhere. That's another important aspect when you're trying to use this information to predict what is going to happen in your network. So we took the ground truth data that we collected using the pneumatic tubes and the video and compared with those from Strava. And we wanted to see, do they follow the same trend in terms of the spikes and so forth? So the left scale is showing total counts. Those are the ground truth data, and the right scale is showing Strava data. And as you can see, the two graphs are kind of following each other. There is good correlation between 6 a.m. and noon and 6 p.m. and 11 p.m. If you look at those trends. And then the other thing that was important for us to think about was the Strava penetration rate. And the penetration rate here means what percent of people, what percent of cyclists are actually using Strava fitness app. And we looked at that by different attributes. For example, the hourly, we looked at different time of the day. We looked at different types of facilities, and we looked at different land use types. And what we found was that maximum Strava penetration rate was in the PM hours, between 3 p.m. and 7 or 8 p.m. That's when you see a lot of cyclists using the Strava app. And I think that coincides with the other observation that we made, which was that people tend to use the Strava app when they are on recreational trips. And probably this is the time of the day when people are making recreational trips and not commuting trips. And fewer Strava users along roadways with no dedicated bicycle facilities. And significant portion of Strava users were using bike lanes and trails and on recreational trips. So overall, what we found was that there is about 70% of cyclists who use Strava app. Okay? Remember, there are other people who use other types of fitness app. And then we looked at weather data. We collected weather data from these stations. And then we tried to kind of check, does weather impact the number of cyclists that you see out there? And I think it does. We all know that. Of course, if it is raining, less people will be riding bike. If it is snowing, you won't see that many people riding. And in this case, we looked at relative humidity, tried to compare relative humidity with the number of cyclists. If you were to look at towards the end of the right-hand side of the chart, what we see is that you look at the total number of the frequency of relative humidity and the total number of cyclists, you see that there is a deviation. And that deviation is actually signifying that cyclists tend to avoid riding in high relative humidity. That's why we see the total number is going down when the relative humidity is actually going high. It's going up. So the other thing that we did now, we took Strava data and we looked at other data that we had, like infrastructure information and other factors, and we tried to do modeling. And we did a correlation analysis first, and we wanted to see, is there a good correlation between the Strava data and the total counts. And we found that there is a good correlation. And the other factors that we had in our model had a good correlation too. And we implemented different modeling techniques. I'm not going to go into these modeling techniques at the moment, but we had probabilistic models and we had machine learning models, and we divided our data into two groups. We had 70% for estimating our models, and we had 30% for testing how good the models were working. And we used two performance measures, the root mean square error and the R squared, to check the prediction capability of our models. I apologize for the slides. They don't show everything. I don't know what's happening. In my computer, it is showing everything, but doesn't show very well there. These are the results for the probabilistic model. And it's actually showing that a unit increase in Strava cyclist count increased the hourly cyclist counts by 9%, meaning that if you have information from Strava data, you are increasing your probability of predicting the total number of cyclists by 9%. That's what it's saying. And the unit increase in relative humidity reduces the expected cyclist in an hour by 1.1%. So if relative humidity increases, the number of cyclists goes down. Okay? Trails attract the highest number of cyclists compared to the rest of the facilities that we had. And a unit increase in the percent of workers who were using bicycle to commute to work increased hourly cyclist counts by 21%. So when you have Strava data included in your model and compare with when you don't have it, what do you see in terms of prediction capability of your models? And again, as I told you, we had two performance measures. The left side is showing the root mean square error, and the right side is showing the R squared. And as you can see, when you have Strava counts, you tend to have lower root mean square error, meaning that your model actually becomes better in terms of predicting. And the R squared is showing the same. You have higher prediction capability when you have Strava data. We compared the 5 models that we developed, and the random forest was the best. I'm not going to go into the details of that for now. But the other thing that we thought about is that at the moment we have a 70% penetration rate of Strava data, people who are using Strava app. What would happen if that penetration rate increases? Is that going to be a good thing in terms of predicting what is happening in terms of the number of cyclists? So we did a simulation study where we increased the penetration rate, and as you can see, we increased it without changing the distribution by hour. So that's the assumption we made, that the distribution is going to be the same. Now the penetration rate is going to be increasing, and incrementing the Strava penetration rate while maintaining the observed counts across the sites. So when we checked how accurate the model is going to be when the penetration rate increases, what we found was that when the penetration rate of Strava increases, the prediction capability of the model increases too, which I think makes sense. For example, if we happen to have, say, 100% of Strava data, meaning that everyone who is riding a bicycle is using Strava app, and we can get that data, obviously we can actually know how many people are riding easily. So that's what this graph is showing, that whereas the penetration rate increases, the data from fitness app become more usable actually. They help predict the number of cyclists in the future. So in conclusion, to summarize, is that cycling activities data from fitness apps can improve estimation of bicycle exposure. If we can get those data and incorporate them into the models that we have now to predict how many cyclists we have in our network, it could be useful. There are challenges associated with them. And those challenges include different groups of people may prefer different fitness app. So if we are trying to utilize data from fitness app, maybe we should get data from all fitness apps. That's when we can benefit more. Male cyclists, they use the Strava app more compared to female. Middle age group uses Strava app more compared to the people with age of 55 and above. And there is a difference between proportion of fitness app users in different bicycle facilities. That's another key. When you are trying to utilize the information from fitness app, you got to keep in mind that they are used differently by different types of infrastructure. So that should be incorporated in your estimation. So I would like to acknowledge the USDOT, Transportation Research Center for Livable Communities, and the data we used again was partly from Strava. And I would also like to thank the City of Ann Arbor, City of Grand Rapids, DTE Energy, and Kent County Parks for their support when we were doing data collection. Any question?